All right, first thing, I'll just write the frame out. The first thing that comes in an Ethernet frame is called the preamble. I'll say this is first. Then it goes down. First thing that comes out, preamble, and we transmit 7 octets, and it's just 1, 0, 1, 0, 1, 0, 1, 0, blah, 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 blah. 7 times 8 is what? 56. So I have 56, and it just alternates 1, 0, 1, 0, 1, 0. In case you're interested, that synchronizes the clocks. It's also sort of a get ready here, okay? So A starts transmitting 1, 0, 1, 0, and it's like, hey, a message is about to start. Everyone else synchronizes their clocks, so we want to know, when does a 1 begin and end? When does each bit begin and end, okay? So everyone expects these 1s and 0s, and they can get their clocks all synchronized, okay? That's the preamble. And then this is super elegant here. To indicate that I'm about to start the frame, so here's like the pay attention. The start of frame is 1 octet. It is 1, 0, 1, 0, 1, 0, 1, 1. Brilliant, right? So as soon as I go from going 1, 0, 1, 0, like 1, 0, 1, 0, 1, 0, as soon as 1, 0, 1, 1, this is the start of the frame. All right? The first thing in the actual data part of the frame, and we're okay, this is completely overhead here, right? There's nothing but overhead up here. Next thing up is the destination address, okay? The destination address is called a MAC address. I'll put that here. And that is 48 bits. This is a 48-bit address, and I'll just talk about it over here right now. 48 bits long. How many octets is that? 48 bits. Oh, it is. Pay attention here. Okay. So it's 6 octets long. MAC address. Media access control is what MAC stands for, except there's only one L on it. No one cares media access control, though. It's MAC address. This is set by the factory. All right? So it's our 6 octets. And what they do there is, each manufacturer is given a certain sort of first few octets, and then they can set the remaining octets themselves. So it's set by the factory, 6 octets. It's written in hex form. I'm sure this is from 317, right? You guys did some hex. You guys remember hex, right? I don't want to get too much into this because there's not a lot of point in it. So I'll just write one randomly here. What are we going to do here? So if I do 0, 1, 1, 1, that actually ends up being a number 7. All right? And you guys know if I get above 9, I can no longer write like number 10, like a 1, 1, 0, 0. What's that? Anyway, a 1, 1, 0, 0, I'm not going to get too much into this, right, is going to be written a C. All right? So if my rack address was 0, 1, 1, 1, 1, 0, 0, oops, 1, 1, 0, 0, then that would be a 7C. Are we good here? So in hexadecimal form, 8 bits, that's an octet. And we never call it a byte, right? What do you think 4 bits is going to be called? Don't say it. It should be a quartet. Don't ever call it a nibble, or I will not be. I will think you are the biggest nerd of all. All right. It's a nibble. Yeah, you don't want to say it. Don't say nibble. Yeah, people say nibble, but I'm not into nibble here. So remember, though, this is bits. I mean, no matter what. If we're writing down stuff like this, it's just so we can see it It's easier to write it down, basically. We're good with that, right? IP address is the same way. We write them decimal. So a MAC address, let's see if I got any fancy ones over here. So anyway, you might end up with like A1, B, 3C, D7, 2, 3, F. And so that would be the whole thing. But this is just written out. Sometimes you need these. For example, you might have on your wireless connection where you only want to allow certain computers to use your wireless connection. That means you need to know the MAC address that was set by the factory for whatever laptop. And there it is. So it's in hex form, and you type these in as, this station is allowed to use my thing, right? So MAC address set as factory. One other comment. It's destination first, right? Remember I told you A is transmitting to C, so the destination address is this C, whoever the C MAC address is, and B is going to ignore it. And the way Bob Metcalf thought was, they're going to send this out, and I want to make sure everybody knows that they can ignore the rest early. That seems like a nice thing, right? So if I hear destination MAC address, it's not for me, then I just stop listening. There's more, obviously, to come. There would be. I'm going to have the source MAC address. So who is sending the frame to me? Of course, that's 48 bits too. Then I'm going to have the length. This is an old frame, and that's fine. The length of this is 2 octets. And these could only be a certain length long. This is how long the data itself is. Okay. And then once we have the length, we're going to have data. And the data can be up to something, I don't remember what it is. And then you have a pad. The pad is there because there is a minimum size. And this is more trivia now than actually something we care too much about. Remember I told you our 1s and 0s are propagating through our cable here. If this cable gets really, really, really long, so if it goes way, I don't know, and I wrap and I wrap and I wrap, and let's say we go over the limit of how long we're supposed to go, I don't know, we get down here somewhere, and I've got a station down here. In case you're wondering, these can be up to 500 meters long. So let's say I get up to, and I'm right at 500 meters, and there's a station down here. What I need to do is make sure when A broadcasts their bits, I need to have them reach all the way here before A stops listening. Isn't this crazy? Because remember, A has to listen and hear a collision. So imagine if the whole frame, this is going to get your brain around this one. Let's say the whole frame that A is sending takes up half of the garden hose. Okay? So it's zipping along here. And this is where it begins, preamble, blah, 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 and then it ends right here. You ready for this? So this faraway station doesn't hear it, and it starts sending out its frame at the same time. This is so much fun. Come on, you guys know this nerdy stuff is great. If it's timed just right, this computer will be able to send out as much stuff as it can, such that that message would be just getting to A when A finished. And A, if the frame is not long enough, they might not detect a collision. Okay? You guys understand intuitively, right? If you don't think there's a collision, you think everything's fine. If there is a collision, you got to fix it. We good here? You don't need to get your brain too much around that. But. So there, that's what the pad is for. Whoops, pad. We need to have a minimum size. And the pad, it just has to add, the data in the pad had to add up together. This last field is the frame check sequence. And this is 4 octets. And we'll put here the frame check sequence detects errors. Okay? So if there's an error in the frame, they'll do some calculations. I'm not going to even tell you. Well, I'll tell you. It calculates its own frame check sequence based on what it got, and then it compares to the frame check sequence it received, just to make sure it's okay. I talk about that a lot here? I don't. So we'll talk more about error detection later. That'll be fun. All right. So that's fun.